Now, what we are going to look at next is the velocity. Now, what
Okay.
is the average velocity and what is the difference between velocity and the speed? Okay. Now, velocity is a vector quantity. It
Mm-hmm.
has direction. Compare with speed, speed has no direction. Okay. Then velocity is defined as the change in displacement, the final displacement minus the initial displacement, then divide by the change in time. The change in time is the final time minus the initial time.
Initial time. Okay.
Okay, so if we now average, the average is denoted by a bar at the top there. Now later on we will learn about the instantaneous velocity. The instantaneous velocity has no bar at the top. Bar here means the average. There's a bar on top means there's an average. That means it's the total displacement divided by the total time taken. Okay,
Okay.
one more time. Average velocity is given by this symbol V with a bar at the top. A bar at the top indicates that it is average. Without the bar, then it is just velocity. It can be the it can be the instantaneous velocity, it can be the average velocity, and they're two different things, right? So with a bar there, it is average. Without bar, then it could be just velocity or instantaneous velocity. Okay, so how is the average velocity defined? The average velocity is defined as the displacement divided by the time interval. Okay, what is the displacement? Displacement is the final. I better get a mark, make a mark there so that you know where I am
Oh,
referring to.
I know where you are. I know where you
Okay, so displacement over the time interval. Okay, how to find displacement? It is the final position minus the initial position.
are. Position.
Okay, if you want to find the time interval, it is the final time minus the initial time. Okay, so we put it in other words. In another word, it is change in position divided by the change in time. And as we have seen earlier, change in position is given by this symbol delta x. Delta means change. Change in time is the delta t.
Okay.
Okay, and this is the standard symbol. Whenever you see
Mm-hmm.
the symbol delta there, it means the change. The initial, the final minus the initial. So what is the change in x? Final displacement
Placement
minus
over
the
initial
position. Sorry, final position minus the initial
minus the
position.
initial position
So the same thing.
over final time over minus
Mm,
initial time.
okay, correct. Now, in the table here, the table 2.1 shows us, where am I going to put this bar here? Okay, put at bottom. Now, the table 2.1 shows us the position, the time,
Mm-hmm.
and the displacement. Okay, so at position A, the time is 0 and the displacement is 30. Position B, the time is 10, the displacement is 52 meters. Okay, and so on. Okay, and so on. The
Okay.
graph is actually, where is the graph? The graph is here. No, the graph is actually here. This one. So the position A is here, then B they go up, then come down, and so on. So
Okay.
the graph shows the various position of the car and their time respectively, the different position and the time respectively.
Okay.
Okay, so coming back to this table here, probably you see numbers, you cannot visualize what is going on. But actually, it will be something like this. They show you the different position. They are not displacement, they are different position during different instance. Okay, during the 10th second the position is here, during the 20th second the position is here, and so
Okay.
on. Okay, coming back to this question here, right? What is the average velocity from A to B? Let's say, right? You want to find the average velocity from A to B. So using the definition here, or either one, you think of it as this, the displacement, the change in position divided by the change in time. So, so A is the initial position, B is the final position. So
Position.
can you find the average velocity from A to B? That means you start from A, you end up B. So B is the final one. A is the initial. So can you use
Mm-hmm.
this formula to find the average velocity from A to B?
So you do 52 minus 10 over 30 minus 0.
No,
51.
no, no, no.
Alright.
It is displacement, the position minus position, not position minus time.
Oh, okay, I got it. Sorry,
The
sorry.
top, the column and column.
49.
Okay, what is the answer?
49.
49. 4. Okay, never mind. I show you, right? I show you.
Oh, 2.2.
2.2. Okay, correct. Now, from A to B, the final position is 52. At B is 52. The initial position is at A, which is 30. So it's 52 minus 30. And what is the time interval? The time interval is 10 second minus 0. So it is 2.2 meter per second. How about from D to E? From D to E, these two.
From
These two.
D to E will be
Ah,
negative 37 minus 0 over 40 minus
okay,
negative 3.7.
correct. It's negative 3.7, right? Negative, oh, I showed the wrong one. This should be the one. Okay, negative 3.7. So we see that uh, the initial position is D, the final position is E, right? So let's say if the initial position is A, the final position is E. So I need to take 37 minus 30. So it
Mm-hmm.
depends on which interval you are referring to, right? So it is not fixed. The average velocity is not fixed. It depends on which interval you are referring to, from 0 to 40 or from 30 to 40. So it depends. Okay, but you notice that the average velocity in the first case is positive, and in the second case it is negative. No, why is it like that, right? Why is it like that? Okay, okay. Now whether the car is traveling in a straight path, that means your distance travel is actually your displacement, or the car is traveling in a crooked path. Even you are traveling in the crooked path, we are not interested in the crooked path. We are only interested in where is the vehicle initially
Okay.
and what is the position finally. So we don't care whether they're using a crooked path or straight path. Straight away we say it is displacement, final displacement minus initial displacement divided by the time interval. So it is this position and this position. We don't care whether crooked or straight path, right? So this is
Okay.
what I meant by irrespective of whether the car is traveling in a straight line or a crooked line, we still use the same definition. We still use the same definition for average velocity. Okay. Okay, this is the first thing you need to note, whether they are straight or crooked, still we use the same method to find the average velocity. Then the second one, positive velocity from A to B means the car is heading in the positive direction. Now this can be judged by the position of the car. Now at first it is 30, finally it is 52. That means it is more towards the right, so that means the car is traveling from left to right. Okay or not? At first
Okay.
it is 30, finally it is 52, so it must be traveling towards the left side. Okay, if you cannot see, then you refer to this number line
Okay.
here.
Okay.
Okay, so
Mm-hmm.
at first you are at this position 30, then finally you are at this position 52. Now what does this mean? The car is traveling in the positive direction. It is from the left towards the right, right? So
Mm-hmm.
finally we end up having the velocity a positive number, now
Okay.
from D to E, at first it is at D, which is 0, then finally it is at negative 37. So you look at the diagram again, right? Where's the diagram? This one. Okay, at first it is at this position here, 0.
Okay.
At first it is at this position, 0. Finally it is at this position here, negative 32. What does that mean? At first it is starting from here, then finally it is here. So it means that the car is traveling from right to left, So it is shown by the negative velocity. So it is shown by this negative number here. The negative means it is moving towards the right. Positive means it is moving towards the sorry. Positive means moving towards the right. Negative means moving towards the left.
Left.
That's why we have this different sign for the velocity.
Okay.
Okay or not?
Yep.
Okay, right. So now we're going to look at this quiz here. Quiz 2.1. Can you read this 2.1?
Figure 2.4 shows the unusual path of a confused football player. After receiving a kickoff at his own goal, he runs downfield to within inches of a touchdown, then reverses direction and races back until he's tackled at the exact location where he first caught the ball. During this run, which took 25 seconds, what is A, the path length he traveled, B, his displacement, C, his average velocity in X direction, and D, his average speed?
Okay, right. Now, this football player, right? He
Mhm.
runs from one end of the field to the other end of the field and turn back to the starting position X here. Okay, so I want to ask you, the initial position is where? At this X here. Final position is where? Come back here. Final position also at the same point. So what is the path length he travels? Path length take into consideration all the crooked line, all the curves and so on. So can you tell me what is the path length?
Mm, how do you find out?
How much is the distance moved by this football player?
200 yards.
How many yards? 200 yards, correct.
200.
200, correct. You go forward 100 to the right hand side, then come back another 100. So the path taken is 100 plus 100, which is 200 yard. Now, what is his displacement? Now, if you remember the definition of displacement, it is the initial position and the final position. We use the
Mhm.
final position minus the initial position.
Right.
What is the initial position? Can you look at this number here?
0,
What is the final one?
100.
No, finally they turn back here, come back to the same
Mhm.
position. So what's the final position?
0,
0. So what is the displacement?
0.
Is 0. It is 0, correct. Now his average velocity. When you want to find the velocity, you use the path length or you use the displacement.
Okay.
You see, earlier on you have found two numbers. The first number
Mhm.
is the path length, which is
200.
200 meters. And you also found the second number, which is the displacement, 0, right?
0.
Okay, so now you want to find the average velocity. Which number you're going to use? The
Ze-
first number or the
The,
second?
the the first one not, because the second one 0. Or should we
Uh,
use 0?
you want to look again at the definition of velocity. Now this is the
This
definition
displacement
of
over time interval.
displacement over time. So what is the average velocity?
0.
0, correct, 0. Now if you want to look at the average speed is defined as this. Average speed is defined as this. Can you see this formula here?
Path length versus elapsed time.
So can you tell me what is the average speed?
Path
Average
length
speed.
is 200 yards, right?
Then divided by.
Then elapsed time, which is 25 seconds.
Correct. So this is what you're going to get. So the first two parts, you find two different numbers. The
Okay.
first number is the path length, which is to and fro 200, and the second part you find the displacement, which is the final position and the difference between the final and initial position. Then the last two part you have to find the average velocity and the average speed. Average velocity you make use of displacement, average speed you make use of the path length. And when you divide, you get 0 velocity and average speed 8 yards per second.
Okay.
Okay, this one you told me everything, so you should understand. I can go
Mhm.
on to the next one.
Yep.
Okay, next one. This one.